Hello, in this video, we're going to look at how a perfectly competitive firm responds to cost changes. A perfectly competitive firm has a total cost equation given by the following. We want to show that an increase in B, right over here, an increase in B, reduces a firm's profit maximizing output. We begin by taking the derivative of the cost equation with respect to output. So the derivative of AQ is A, and the derivative of BQ squared is just 2BQ. For a perfectly competitive firm, it maximizes profit by taking the price and setting it equal to marginal cost. Perfectly competitive firm being a price taker. So we'll take P and set it equal to our marginal cost equation. Now I'm going to solve this equation for Q. So moving A to the other side and then dividing through by 2B. This represents the profit maximizing output for a perfectly competitive firm given this marginal cost structure. So rewriting that last result. We want to show how an increase in parameter B here affects the firm's output decision. We can do that by taking the derivative of this equation with respect to B. So following the quotient rule, we're going to get this result. And this derivative result is less than 0. It's negative. So the derivative is negative. And we know it's negative because this P here, in parentheses, a price, is going to be greater than A, parameter A. If P is less than A, then price would be less than marginal cost. And in perfect competition, price needs to equal marginal cost. If you recall, again, in perfect competition, price equals marginal cost. And our marginal cost equation was A plus 2BQ. So price definitely has to be bigger than A, has to be greater than A. If not, price would be less than marginal cost. One other thing we can do here before wrapping up is just rewriting that profit maximizing output. And this time, let's see the effect on the profit maximizing output from an increase in parameter A. Once again, we can do a derivative here, this time the derivative of Q with respect to A, and we just get minus 1 divided by 2B. Here again, we get a negative result. So the derivative is negative, so as a parameter A increases, that parameter A in the total cost equation, as that increases, the profit maximizing output decreases. Okay, I'll stop here.